This is the beginning of Lecture 16, Part 2. In Lecture 16, Part 1, we answered the question, is all UV radiation the same? And it's not. There's a spectrum of UV radiation of varying wavelength and varying energy, just like any other region of the electromagnetic spectrum. We looked at how the UV light is filtered in the atmosphere by oxygen and ozone, and that oxygen will filter out the higher energy ultraviolet light, UVC region, but not the lower energy UV light in the B region because the chemical bond is too strong to be broken by the UVB. However, fortunately we do have ozone present, which does do a good job of filtering most, not all, but most of the ultraviolet light in the UVB region. Now, the reason why we talk about oxygen getting most of the UVA is because, or excuse me, UVC, because oxygen is, the second most abundant gas in the atmosphere. The first most abundant gas in the atmosphere, which we haven't mentioned yet, is nitrogen, and nitrogen doesn't do a good job of filtering B or A because nitrogen actually is held together by a triple bond. The nitrogen in the atmosphere is held together by a triple bond, which is an even stronger bond. And so the UV, it's way too strong of a bond to be broken by UVA or UVB. All right, so this particular graph is showing the biological sensitivity of the different energy or different wavelengths of light. And you see that people, they're obviously very, very sensitive to C, but C doesn't make it here, so we don't have to worry about it. But the sensitivity, the higher the energy, the more damaging the radiation. All right, so the biological sensitivity, this is the way the scale works is the sensitivity is how much damage does that particular wavelength or energy of ultraviolet light due to DNA. That is, to what degree is are the bonds within DNA broken? And you see that it's a relative scale, but it's a log scale. So a lot more damage is done to DNA within the UVB region at the lower end of the spectrum around 280, and then it varies. And then down the UVA does very little damage to DNA. So the biological sensitivity then is, is it going to damage DNA? If you damage DNA, one of two things can happen. You can either cause genetic defects, which is that would be damaging DNA in an egg or a sperm, or that's going to be carried on to the next generation, or you can actually damage DNA within cells that are replicating within a living organism that causes cancer. So it's one of two things, because the regular control mechanisms within the cell get disrupted when certain DNA is disrupted that can then lead to cancer. So when we see DNA damage, the type of damage is either genetic damage or cancer-causing damage. All right, so this is just to show you that yes, within the UVB region, it is very damaging, and it's a good thing that we are filtering out that UVB radiation. The UVA makes it down, but it's not such a big deal because it doesn't do as much damage. Okay, so other than the DNA damage, then what does the UV radiation do to you? Well, the higher energy, the UV radiation, and just let's talk about you as a person. At the higher energy, the ultraviolet is similar to ionizing radiation. Just like from if you're exposed to nuclear radiation in a high dose at a close-in proximity, then you could get a burn on your skin. Or if you're exposed to high temperature, even, you can get a burn on your skin. And it's the same thing that the ultraviolet radiation can do. In the short term, if you have a high dose of ultraviolet radiation, it can burn you. And that's the same thing as ionizing radiation. It actually breaks the bonds. It causes first the skin to turn color red and then even blister. And so it can burn. Long term, so that could be short term. Short term effect would be like a like any kind of ionizing radiation or chemical burn. It causes a burn. On the longer term, it can cause DNA damage. Over time, it takes a lot of DNA damage to have a long-term effect, which can lead to cancer. And in particular, the type of cancer that it would lead to is skin cancer in humans. Okay. It can cause, yeah, I'll just leave it at that. Now, as it turns out, when you're exposed to ultraviolet radiation, in the short term it will burn, but if it's a longer term thing, your skin actually changes colors and becomes more brown. And that is due to the natural chemical response in your skin to ultraviolet radiation is the production of more melanin. And melanin is what gives your skin the brown color. Now, if your skin is already brown, that means that you have, the way you are genetically made up is you have more melanin in your skin. If your skin is lighter in color, more white, that means the way you're genetically made up is that you do not naturally have very much melanin in your skin. But if you're exposed to ultraviolet radiation, your body will naturally produce more melanin if you are of the genetic makeup and have the type of skin that is capable of producing more melanin. Some people have absolutely no melanin, and some people have a variant of melanin, and they never, their skin never gets more brown as a result of sun exposure, ultraviolet light exposure. So anyway, tanning is the natural way of protecting against the ultraviolet radiation, because what happens is if you have more melanin in your skin, the pigment in the melanin actually absorbs the ultraviolet radiation before it can be absorbed by the DNA, or just the like the burn itself is just being absorbed by the carbon-carbon bonds or the carbon-oxygen bonds in your skin that literally break down the skin and cause it to turn red and blister and whatnot. It's literally a chemical change. Let's see, it can also it affect your eyes. So your eyes absorb ultraviolet light, and it can lead to the formation of cataracts, long-term ultraviolet exposure. That's why you should wear sunglasses. Now this is all the UVB region. The UVA it doesn't burn your skin. It's not strong enough to burn your skin, but over time it will cause more melanin to form in your skin and will cause your skin to turn more brown. Now, over time, as people have lived for hundreds of thousands of years in different regions of the world, people have evolved to have more or less melanin naturally as a protection measure against ultraviolet. So that's why people who live in more central latitudes and sunnier places in general have darker skin naturally, because over time people have evolved to have darker skin. Whereas if your ancestors evolved in latitudes where there's not as much sunlight because the days are shorter, and they weren't outside exposed as much, or they had more hair and or clothes over their skin, then they wouldn't have over time evolved with as much melanin in their skin. But nevertheless, even though melanin does prevent skin, well, let me get to that in a minute. I don't want to get ahead of myself. I want to tell you one more thing about UVB radiation, and that is that it's not all bad, that some limited exposure to UVB is actually good, because in your skin it also initiates the process of the synthesis of vitamin D. So vitamin D, UVB, initiates the synthesis in your body of vitamin D. So you don't have to ingest vitamin D from some external source as long as you get a little bit of sun exposure, because you will, unless you have some kind of metabolic condition, you will naturally make your own vitamin D. So in that case, it's good. All right. Okay, so that's what UV radiation does to you. It can burn your skin, it can brown your skin, it can eventually do DNA damage, and which can lead to skin cancer, but it also at the same time, small amounts aren't so bad because it can produce some vitamin D.